Okay, now we're going to look at linear modeling part 2. And the only thing different here is a different setup of equation. Really, the ideas of the previous lesson are the same. And let me review what those ideas are. With linear modeling, what we're going to try to do is use linear equations and everything we've learned about linear equations to model, to try and show a real world or quasi-real world. In grade 9, we're still sometimes just sort of making up situations to practice our skills on for later grades, but sort of real life situations, and using the skills we've gained through linear relationships to do some math on the situation. So that's all modeling means, is we're trying to fit a real world situation into the math we've seen. So here's the problem we're going to look at. Derek is saving money to buy Mr. Todd a fantastic end-of-year present. He currently has $8.40 in only nickels and dimes. So apparently Derek's saving idea for this present is that every time he has a nickel or dime in his change, he puts that in his piggy bank. And, if he has quarters, loonies, toonies, maybe he spends those, but he's going to save all the nickels and dimes up. So he knows in his piggy bank is only nickels and dimes. So the first question says, create an equation to model Derek's current savings. So to handle this, what we're going to do is first set up the two variables in this situation. And now, not like last chapter where we were worried about two variables, we're not worried about two variables here at all. We can do questions with two variables now. And so what I'm going to do is go let n equal the number of nickels he has, which we don't know at this point. We don't know how many nickels he's saved up. And I'm going to let D equal the number of dimes he has. And then I got to do some thinking. Sometimes the let statements are pretty easy to get down, and then you got to think about what the equation will be. Now, we know he has a total of $8.40. So whatever my equation is, it's going to come out to $8.40. So I find that easier sometimes when I've got a situation where there's a lot of information going on and I'm a little confused about everything that's going on. I can say, well, I know it adds up to $8.40, so let me put that over there, and at least I've got part of the equation taken care of. Now, where does that $8.40 come from? Well, it comes from nickels. So how does the money come from nickels? How much money does he get for each nickel? And the quick answer is 5 cents. But it's not really 5, because the way I've set this up with $8.40, 8.40, if I use the number 5, that means it's going to be, I'm saying it's $5 for every nickel. So what I've got to do is use decimals here and go, no, he gets 5 cents. So 0.05. Fix that up there. 0.05 times the number of nickels. Then he gets, okay, how much does he get for dimes? Dimes are worth 10 cents, so I can't use the number 10. I've got to use the decimal 0.10 D. So that's where that equation comes from. 0.05 times however many nickels he has, plus 0.10 times however many dimes he has. That has to add up to $8.40. Okay, so it says determine the intercepts. So we've done a lot of practice on intercepts, I hope. But if not, here's another new explanation of it. If you want the n-intercept, that is where this thing is going to hit the n-axis when I get to graphing it. For the n-intercept, we just set the d value equal to 0. So to hit the n-axis, we'll need a d value of 0. And I'm going to plug it right in here. Some of you might be skipping this step here where you plug it in. You go 0.10 times 0, because it's pretty easy to skip that step. If you're subbing in 0, whatever it gets subbed into is just going to disappear when it multiplies by 0. So you could easily just be jumping to this step here where you're going 0.05 equals 8.40, and then divide both sides by 0.05, and I get an n value of 168. And actually, I'm going to interpret that in the next question. C asked me to explain what that means, so I'll do that in part C. But for now, I'll just get that number. And then for d-intercept, if I want to know where this thing hits the d-axis, if it's going to hit the d-axis, I'll need the n to be 0. And I'll show this step again, even though it's quite legitimate to skip over this one. 0.10D. I've subbed in 0 for the n value there. Ooh, I'm sort of unhappy with the 0 I used over there, so just fixing that up as I go. And so when I multiply 0.05 times 0, I get 0. I get 0.10D equals 840. And this time I'm dividing by 0.10, and I'm getting 84 when you punch that in your calculator. And no statement here, because the next question asks me for the statement. It says explaining the meaning of the intercepts here. And the two intercepts were, if there is 0 dimes, that's the first one I did, there is 168 nickels. That's one of the possibilities of what's in Derek's piggy bank. Maybe he actually doesn't have any dimes. And to get the $8.40, he needs to have 168 nickels. The other possibility is if there is 0 nickels, that's the other one I did, there is 84 dimes. So maybe this is the first time intercepts maybe make real sense to you, where you're like, oh, really the intercepts are about finding 2 nice easy points on the line. These are easy ones to find because subbing in 0 is a super easy number to sub in. And if we're drawing a straight line in this situation, having 2 points is enough. So that's more than enough. Now, the next question is a little bit tricky. It says, determine another possible combination of nickels and dimes he could have to give Derek's current savings. That says we found 2 possibilities, 0 dimes and 168 nickels. Another possibility is 0 nickels and 84 dimes. So there's lots and lots of ways you could come up with other possibilities. So if you're really thinking cleverly and say, well, okay, he could take out a dime, he could have his 84 dimes, and he could take 1 dime out and exchange it for 2 nickels, so we get 83 dimes and 2 nickels. You could do that kind of thinking, and that's very easy thinking and very good thinking. I like that thinking. I'm going to show the most powerful way, because it really does apply to other situations too, where you can just choose the number of nickels and just say, well, maybe he has, and I'll choose 62 nickels. You know, just some random number that I just sort of picked out of my head there. And using this equation up here, I'm going to go back up and highlight it because it's such a good equation. There's my highlighter right there. That equation that goes all the way across there is extremely powerful. It really can find you any combination you want. So I'm going to make 62 nickels. I'm going to go 0.05 times 62 plus 0.10D equals $8.40. And then I get out my calculator and I type 0.05 times 62 in to figure out how much money he has in nickels. And I find out that he has $3.10 in nickels. Then I can move that over with my equation solving skills from last chapter. And so I get 0.10D equals, let's see, 840. Subtract 310, I get 530. And then divide that by 0.10, and I get 53. And I'm pretty unhappy with the way my 5 looked there, so I'm just going to fix that up. 53. So therefore, he could have 62 nickels, 53 dimes. That's another possibility. And there's many, many, many possibilities that he could have, but that was just finding one other possibility. And once you have that equation, it's pretty, well, maybe easy is not the right word, but it's pretty straightforward. You just go through some steps to find those possibilities. Next, it wants me to graph the relation. So what I'm going to do is I'm going to write nickels along here and dimes over here. Not a whole lot of room to write in my scale here. And then I'm going to go along number of dimes here. I'm going to go 10, 20, 30, 40, 50. What does dimes got to get up to? 60, 70, 80 was the most, 84 was the most we went to. So I'm just going to go up to 90 here. And then across here, I'm going to sort of double that up just to make sure I got enough space here, 20, 40. When you're doing this yourself, you have to play around and look and say, well, what's a good scale to use here to get to what I want to get to? And the most we got to was, what was it? 168 nickels. So I went up to 180 there. Okay, and here's the real big advantage. Up until this point, you might have been unimpressed with the intercept method. Maybe you totally get why it's so awesome. But why the intercept method is so awesome is when I go to graph this thing, I've got my 2 points. That is, I found out if there's 0 dimes, there's 168 nickels. So that's a point right about, let's see, that's 170 right about there. So right about there is 168, just short of 70. So that's a nice point to have on there. And then the other point I got was 0 nickels, 84 dimes. So that's right about here. And that's all I need to draw my line. Now for you, you just get your ruler out and connect those 2 points. Connect those 2 spots here. I got a fancy ruler here that I'm going to put on here and see if I can get it to work. Connect up those 2 points. Let's see if it's going to let me do the angle here nicely. Oh yeah, it is. Now, here's just a little thing. We just sort of mentioned it in grade 9. Technically, I shouldn't draw a solid line in this situation. And the reason I shouldn't draw a solid line is because nickels and dimes isn't what we call, is what we call discrete numbers. That is, you can't just have any number of nickels. You can't have 62.1 nickels or 41.8 dimes. So just to remind ourselves that all these points are possible, we often draw a dashed line connecting these up. It shows us the pattern, but then reminds people you just can't have any value here. You can only have certain values there. So that's what that's for. More about that in science and stuff later on, but we do mention that this is a situation where you really should be drawing a dashed line. So I did graphing the line. Then slope. You could go through and go y2 minus y1 over x2 minus x1. That's a legitimate way to do it, and that's the most powerful way to do it. There's an easier way here, and so but I'm going to do the powerful way here that will handle any situation. That is, this point here was 0, 84. This point down here was 168, 0. So then when I go m equals y2 minus y1 over x2 minus x1. Yes, I know it's d's and n's, and maybe this should be d2 minus d1 over n2 minus n1. But we're so used to the y's and x's, maybe we want to write it like that. But let me write it the other way just to show you that, yes, in this situation, we really should be using d's and x's. And so what I get for a slope here is 0 minus 84 over 168 minus 0. And I get this weird number, negative 84 over 168, which seems completely weird until I reduce that fraction down to negative 1/2. Negative 1 over 2. That's an interesting answer, and that's why in part G we ask, explain what that means. Well, what that means is the delta D, which how much you change here, divided by how much you change here, that's dimes on the top and nickels on the bottom. And what we're saying is we lose 1 dime for every 2 nickels, which once I say that, I'm sure you're like, well, yeah, I know, 1 dime is 2 nickels. But the math is really bearing that out here, that this line goes down by 1 dime for every 2 nickels. That's its slope. So interesting real-world application of that comes full circle to what we probably already understand about dimes and nickels. Okay, second problem. Mr. Todd is planning a trip to North Bay. He plans to travel part of the trip in his car and the rest of the trip in a small airplane. Interesting. Maybe his car turns right into an airplane. Maybe that's what we have to imagine here. You see how I said they're quasi-real-world examples. We're almost able to do the math of real-world situation. Not quite here. We're exaggerating a little bit here. In his car, he travels at a constant speed of 99 kilometers an hour, and in the airplane, he travels at a constant speed of 220. I've chosen numbers carefully here to make this work out kind of nice in this question. During his journey, Mr. Todd traveled a total distance of 396 kilometers. And it says, create an equation. So then I'm going to do those let statements. Let C equal number of hours in the car. And then I'm going to let A equal number of hours in the airplane. Those are the 2 unknowns here, is how long did he spend in each one of the vehicles. Now, this equation's a little bit harder because we know we have to go to a total distance of 396. And again, I encourage you, when you've got a number like that, it's just to get your equation started, like equals 396. I know the 2 distances have to add up to 396. So let's talk about the distance he goes in the car. And this is sort of difficult to think about. Let's say he is 1 hour in the car. If he was 1 hour in the car at 99 kilometers an hour, he'd go 99 kilometers. Well, what if he goes 2 hours in the car? 2 hours would be 2 times 99. 3 hours would be 3 times 99. 4 hours would be 4 times 99. But here we don't know the number of hours, so actually the distance he goes in the car is 99 times the number of hours. We don't know the number of hours, so we go 99C. 99 times the number of hours in the car. Let's say that didn't make sense to you. Like, I'm not sure where you got that. Let's do it again with the airplane. 220 kilometers per hour in the airplane. Let's say he goes 1 hour. Then I'd go 220 times 1. Let's say he goes 2 hours in the airplane. Then I'd go 220 times 2. So he goes 3 hours in the airplane. Then I go 220 times 3. But here, we don't know the number of hours, so what we're going to write is 220 times A, which is A is the number of hours. Okay? So there's my nice equation, and I'm going to highlight it because it's going to come up later, just like it did in the previous question, where we had to use that equation later. So I'm going to do a nice highlighting job on that so that I can come back and use it when I need to. Okay, it says determine the intercepts for this relation. Well, that works kind of the same as what we did before. For C-intercept, we'll make A equals 0. And I'm going to show you that shortcut this time. If A is equal to 0, then what I just have is 99C equals 396. I can divide both of those by 99. And I've played with these numbers to make them work out nicely for this example. That would be 4. And again, we'll interpret that in a minute. But what does that all mean? We'll talk about that in part C. And then for A-intercept, we'll go C equal to 0. And again, I'll show you that shortcut. If I'm putting in C equals 0 to that equation, it's 99 times 0, so that's just gone. And I get 220A equals 396. Divide both sides by 220, and I get an A of, well, it's a fraction, 9/5. Now, let's see. We've been really on about fractions and thinking that fractions are the end-all and be-all. And we really wanted you to learn lots about fractions. And the reason we wanted to do that was so that when the time came that you needed to do fractions, that you could do them. But maybe we overemphasized it just a little bit. In this particular question, when you're talking about number of hours and these type of things, maybe decimals is the better way to go. So for this question, let's try 1.8, and we'll go with the decimal here because I think maybe that is going to be a more sensible thing to work with as we do a question like this. Never mind that it's a nice decimal, just one decimal place. It's not like some crazy repeated thing, something like that. Explain the meaning of the intercepts. Well, the meaning of the two intercepts is pretty straightforward. The first one is if he goes 0 hours in the plane, maybe the plane's broken, so he doesn't go in the plane at all, he'd need 4 hours in the car. That's the first possibility. The other possibility is if he goes 0 hours in the car, he'd need 1.8 hours in the airplane. So again, just to really hammer home the idea of intercepts here, the idea of intercepts is that we're finding maybe what will amount to the easiest combination to talk about. And if we can find those two easy combinations, that can really help us with the graph. Determine another possible combination. Well, there's lots of really clever things you can do to figure out other combinations, but I'm going to show you the most powerful way, just like I did in the previous question, is just to go back and use that equation. I've moved the screen so you can see the equation up in the top right there, and I'm just going to choose amount. Maybe I decide, here's what I want to do. I want to drive in my car for exactly 1 hour. So Mr. Todd goes 1 hour in the car. If he does that, then it'd be 99 times 1 plus 220A equals 396. See, that's how powerful this equation is. I can find any combination I want, and here I'm going to go 1 hour. So what I get is, let's see, 220A equals 396 minus 99. 220A equals 297. Divide both sides by 220, and I'm already committed to decimals, and so what I get here is A equals 1.35 when I divide that in my calculator. So another combination would be car, 1 hour, plane, 1.35 hours. That's not 1 hour and 35 minutes, by the way. That's 1 hour, 1.35 hours. If you wanted in minutes, you'd have to go 0.35 times 60 because there's 60 minutes in an hour, so it'd be 21 minutes. Those of you going on to physics and science will want to be able to think about that a lot, is that 1.35, when we do a decimal, 0.35, that means out of 100, and hours aren't out of 100 minutes. So if you want to know number of minutes, you got to multiply it by 60. Okay, over to graphing the relationship, and hopefully with these intercepts, life will be pretty straightforward here. What I'm going to do is I'm going to do plane, and this one, and car on this one, on this axis here. And let's see, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 2. Because plane only goes up to, what was the highest plane value? Got was 1.8. This way we got to go 4. So I'm going to go like 1, 1, 2, 3, 2, 1, 2, 3, 3, 1, 2, 3, 4. And, you can play around with the scales yourself and decide what the best scale is for a certain question here. But what I want to get to here is how easy it is to graph with intercepts. That is, one of the intercepts was for C-intercept, A equals 0. So A equals 0, C equals 4. So A equals 0, C equals 4. There's 1 point. And the other point was C equals 0, A equals 1.8. So that's right here. See, bang, bang, 2 points on there. And for you, it's nice and easy. You just take your ruler out and connect those 2 points. I'll get this weird computer ruler on the screen here. See if I can get it to just sit right at the right angle there. Sometimes it doesn't want to on the screen here. It sort of hops around on me. But hey, it worked here. Now, this time, can I connect the dots? And the answer is yes, I can just use a straight line because any combination of hours is possible. It's not like dimes and nickels where you can't have certain decimals or so on. You can have anything you want here. So here comes the straight line. That went pretty well. Turn off that ruler, get it out of there. There, I've graphed the relation. Determine the slope of the relation? Well, I'm going to do this another way. You could do y2 minus y1, x2 minus x1. But when you've got a nice line like this with intercepts, there actually is an easier way. Just a reminder about slope is that you could just do rise over run here. And I can see the rise and run right on the page here. The rise is negative 1.8. The run is 4. I can see that right on there because those are the points there. This is 0, 1.8, and this is 4, 0. So you could go back to the original equation for slope, which is just rise over run. And again, you could do y2 minus y1. And then when I get a weird answer, when I divide that, I get negative 0.45. So my last job in this question is to interpret what that 0.45 means. And what that 0.45 means is for every hour in the car drops the time in the plane 0.45 hours. Does that make sense? Yeah, because the car isn't taking as much off the trip as it could. It's only taking 0.45 hours out of the time that's in the plane. We could have interpreted it from this version of the slope here and say, hey, for every 1.8 hours in the airplane, it's 4 hours in the car. And that also makes sense for the situation and the numbers we've got. So that's linear modeling part 2, really designed to go after the questions that are sort of better set up for doing intercepts. These equations were better set up for doing intercepts because they weren't C equals or Y equals or A equals. They were sort of convoluted equations like these linear combinations of things, 99C plus 220A, or the one up here, 0.05N plus 0.10D. You could do them with Y equals MX plus B and solve for one of those variables individually, but they work a little bit better as intercepts, I think. really try out that homework, because word problems, while difficult, I won't deny that word problems can be difficult, can be mastered with practice. The more of them you do, the better off you'll be. Have a great day.